I wanted to talk about the graphs that you'll be using in this lab, how to interpret them, how to read them, and how to get the data you need from these graphs. So these graphs are supposed to show the motion of the mass in a spring mass system that's exhibiting simple harmonic motion. And so you can see it's going up and down and up and down and up and down, the graph is. And this is the sinusoidal waves here. This is the simple harmonic motion. Now you notice this part in the beginning where it's just a flat line. That's because what would actually happen in a lab if you were taking this data in the lab is you would pull the mass back and you would be holding it in place, letting the equipment go, the detector going before you let it go. So this is a period where you're holding it, the mass is not moving, it's just sitting there, and then you release it and then it starts exhibiting simple harmonic motion. And in the lab, the online lab here, you need to figure out ultimately how long it takes for 10 cycles. Now, first off, what the heck is a cycle? The simplest way to do it is going to be peak to peak. Now, I'm pointing at peaks. You can also point at the valleys or the troughs, whatever you want to call them, trough to trough, or you could just call these peaks too. It doesn't really matter. But going from here to here or from here to here, that's the easiest way. There are other ways to do it too. I'm not going to go through every different possibility. This is what I recommend, going peak to peak or, again, trough to trough, whatever. And so, for example, if I was doing that here, you can see if I start here, I've got 1, 2, 3, 4, 5, 6, 7 cycles showing here. Now, in your graphs in the online lab, you'll have at least 10 cycles. Sometimes you'll have more than 10, but you'll have at least 10. I've only got 7 in mine because my artistic skills are limited. Now, in the lab, it says, okay, you've got to get the time for the lapse time for 10 cycles. And first, it says, okay, how do you get T0? Okay. Now, T0 is, you can think of it as the initial time, but it's not the very beginning. Okay. It's the beginning of when you're counting the cycles. So, for example, if I'm choosing to start here, okay, if I'm choosing to start here, and instead of having to count 10, because I don't have 10, let's say I have to do 5. Okay. So if I'm choosing to start here, then from here to here, this is 0, that's where I'm beginning, this is 1, and then this is 2, and then this is 3, and this is 4, and this is 5. Okay. So right here, if I go, this is where I started, I go down, this, whatever that reading is, that's my T0. So you'll have to look at the graph and estimate as best you can what that value is. And of course, it's an estimation on your part. Certainly some suggestions are clearly incorrect, but you're estimating as best you can, and that's where the uncertainty comes from. And you have to decide, how much could your reading of the graph be off by, and that's your time uncertainty. But that's T0 going all the way over here. This would be my T5. Now you need to get T10. For me, it's T5 because again, I don't have 10 cycles to do. So from here to here, this is what I would be doing. You would have it for 10, but it's the same idea. And you have to take these readings. And each of these readings has an uncertainty associated with it. And so that's what is, there's that box there that says time uncertainty. You're putting it in. Based on the time scale, how much could your reading be off by? And then you have to get the uncertainty of the average period. That's pretty simple, and the formula is right there, but you're just dividing that. You're dividing that time uncertainty. Yes, you're taking that time uncertainty and dividing it by 5, as you can see in the formula there. So that's all you're doing with these graphs. Again, this beginning part, that's where the spring is held, it's not moving, then it's let go. You need to get the elapsed time for 10 cycles. So you need to pick your starting point Now, you can't pick any time sooner in this because it hasn't started simple harmonic motion. This is the absolute earliest that you could pick. And again, I recommend going peak to peak when you're counting your cycles, or again, trough to trough. It might be appropriate for you to go trough to trough. It depends on how your graph looks. But you count them, and where you start, that's 0, so that's T0. And then over here, where you end, for me it was T5, for you it'd be T10 because you're counting 10 cycles. And that's it.